In the late stages of my game, the performance can absolutely tank due to the high number of objects the collision engine has to deal with. This is a critical issue that I need to tackle before I can release the game, but luckily there are a number of solutions I can implement to the engine to help reduce strain on the system. How's it going everybody? I'm Lewis, also known as Scaffles, and welcome to the 37th devlog for my Iron Age fantasy tower defense game, Project Torrim. Last week I revamped the bases in the game, which was incredibly well received. I was unaware at the time, but it is quite a unique system that other tower defense games don't have, and will help Project Torrim stand out. I'd like to thank everybody that liked and commented on that devlog, and when you get to the end of this devlog, please leave a like and comment, it'll be much appreciated. So what's going on this week? This week I need to implement performance improvements to my collision engine as the game can get significantly laggy when there are a lot of objects on screen. I'll take you over the basics of collision, performance tweaks I already have, and show you the new performance tweaks I'm adding. The basics of a collision system are quite easy to understand. There are a number of objects in the system. Each object must check itself against all the other objects in the system to see if they collide. This method guarantees every collision is found, however isn't very scalable in a real-time environment because it relies on nested loops on the same data. This means every object that is added to the system increases the number of checks required exponentially. In Big O notation, this system can be described as ON squared, where O is the number of checks and N is the number of objects. So how can we improve on this? Unfortunately, in Big O notation, the biggest term always dominates the results. However, there are a number of approaches you can take to split N up and improve the performance. I'll explain the approaches I've already used and what I'm planning on adding. I'm hopeful my ideas improve the system, but if anyone knows any better solutions, please let me know. The first performance improvement is to introduce layers. Objects can be split into layers, which means objects from one layer don't have to worry about objects from another. Meaning no longer does collision code have to run for everything, just once per layer. This is something I implemented way back in Devlog 1, and I have layers for general, physics and navigation objects, and I could add more if necessary. Areas are another performance improvement. Objects in one area know they aren't colliding with objects in another, meaning once again the collision code doesn't have to run for everything, just once per area. However, this comes with the caveat that the system must check which area each object is in, which depending on the number of areas and the size of the areas could be a detriment to the performance. This is something I implemented back in March last year, and each system can specify how big an area it wants, which allows me to tune the performance how I like. Flagging objects in the system as active is another really great way of improving performance. Instead of every object checking against every other object in the game, only the active objects make those checks. This is something I currently have set for objects that run an event when they collide. However, I'm not happy with this, as many objects such as towers are predominantly static throughout the game, but will still be running those checks. This brings me to the first change I want to make this week. I want to only flag objects that move as active, which means any static objects won't have a huge effect on performance. The second change I want to make this week is to give objects a list of collisions they care about. This allows them to limit the number of checks they do against other objects. For example, projectiles care about hitting enemies, but do not care about hitting towers. With these improvements in mind, I'm going to get to work. Okay, let's see if it works now. Nope. What's causing this? It's come to the end of my development week and it's been a bit of a rocky journey, but it looks like it's working and I'm pretty happy with the code. Perhaps I should split it into more descriptive functions for readability, but logically I think it's quite sound. The system now only tracks objects that move as active and limits the collision checks to only those that each object cares about. But have these changes actually helped? I put in a stopwatch class to test how long it takes for each layer to run its collision checks across all of its areas. I ran this for the old engine and the new and collected all the results. To make sure this was fair, I loaded the same game save and let it run for about a minute. I took the data and trimmed out the smaller collision layers as I wanted to focus on the main one that has to do most of the work. I then put in over 2,000 samples of that data into a spreadsheet and averaged the results per engine. The old engine average was 1.13 milliseconds, whereas the new engine average is 0.15. That means the new system takes 13% of the old time, which is 774% faster. Whilst these results have to be taken with a pinch of salt because they were taken in just one scenario, I think they're absolutely fantastic. I never expected such a dramatic improvement, and I'm glad that I made these changes. What do you think about this devlog? Let me know in the comments below. I know usually I focus on game content, but recently I've been asked about engine development, and this video was a way of dipping my toes into that water. Next week I'm planning on participating in the 2021 Global Game Jam, and we'll be releasing a devlog for that the following week, with Project Torrim videos continuing after. Don't forget to subscribe to get notified when those videos are released. I hope you've enjoyed watching this devlog for Project Torrim. Leave the video a like to let me know you did. Thank you, and I'll see you next time.